Good morning and welcome to a new chapter and a new session in business math. We have two more major sections to do before the end of the semester. This one is chapter 6. It is the interest formula and simple interest. What we're going to do when we complete this section is then move on to one last unit called compound interest and annuities. That'll be chapter 7 and chapter 8, and those will be the last two modules we're going to do. Generally, students find these two sections the most interesting, particularly the compound interest one, because it deals so much with what we're doing with borrowing money for things that we want. Keep in mind that we can still get by with any calculator in this section, but we absolutely must have that financial calculator when we start chapter 7. I would encourage you, if you don't have it already, however, to get the financial calculator. What I'm going to be doing is showing you how to store stuff in the memory. We'll be getting a good feel for how to use it during this session, this particular chapter. So work on getting that financial calculator so that you've got it when we need it. Okay? So is everyone ready to go on the interest chapter? Simple interest. Good. Interest. It's a fee paid for the use of someone else's money. If you borrow money from someone else, you would expect them to pay you interest. Or if you went to the bank to borrow money, if you used someone else's money, you would be expected to pay interest. Likewise, if you put your money in the bank, you would expect the bank that uses your money while it's in there to pay you interest. So depending on whether you've got the money and you're putting it in the bank or you're at the bank borrowing money, you could either be paying the interest or you could be receiving interest. Two basic types of interest that are in common use today are simple interest and compound interest. Everything we do in chapter 6 will be simple interest. Then what we'll do when we start chapter 7 and 8 is we will discuss compound interest. Anyone know the difference? Anyone got an idea about what the difference between simple interest is and compound interest?
Simply, you only pay it on the amount of money that's in there. Mm-hmm. On compound, you pay interest and the amount of money that's in there.
And that's a great explanation. Simple interest, you are charged interest only on what you call the amount of money that's in there, and the amount of money that's in there we're going to call principal. Okay? For example, if you borrow money for something, then you only, if you're paying simple interest, pay interest on the amount of money that you borrow, the principal. If you pay compound interest, and give me an example of something that you might pay compound interest on. Credit cards, perfect example. If you don't pay off the balance, not only do you owe interest on the principal, the amount of money that you've borrowed or put on your credit card, you owe interest on the interest that you carry over each month. Mm-hmm. That gets to be a complicated procedure, and when we do compound interest, we're going to use these financial calculators to do that. We're not going to do that. They are more complex calculations, and that's when we need these. And the financial calculator has that built in, and none of those scientific calculators that you've been using will have that compound interest formula. That's why we need those. One of the most important formulas that we'll memorize in this class is the interest formula. It's I equal PRT. Let's see if we can get it up here. The I stands for interest. And by definition, interest is a fee paid for the use of someone else's money. P is going to be principal. Principal is the amount of money that is borrowed. R, when we put that in the formula, is rate. And that rate is always expressed as a decimal. So if you knew that the interest rate you were paying was 9%, you would change it to a decimal 0.09 to enter it into the formula. Rate is always a decimal, it's not the percent. Does that make sense? If it was a 12% loan, it would be 0.1 0.12. If it was an 8.5% loan, it would be 0.085. We changed the percent to a decimal for rate. Last thing is time. And time is always in terms of a year. So I like to put a little y under there to remind me that time is in terms of a year. So when I'm using this formula, if the time that I'm borrowing the money for is 2 years, I would put a t equal 2. If I was borrowing it for 4 years, I would put t equal 4. If I was borrowing it for 6 months, t equals 6 divided by 12, or 0.5. If I was borrowing it for 7 months, it would be 7 divided by 12, right? So time always has to be expressed in terms of a year. So for 6 months, you would not put in a 6. You would put in 6 divided by 12. Okay. If I was borrowing it for 3 weeks, it would be 3 divided by 52, the number of weeks there are in a year. Time always has to be expressed in terms of a year. Okay? So, start on example 1. We're going to find the simple interest on $5,000 at 8% for 2 years. Begin with, you write down the formula, which you're going to memorize. The interest is going to be the principal that I borrow, $5,000, times the rate is 8%, so I'm going to change that to a decimal. It's going to be 0.08, and the time is going to be 2 because it's already in terms of a year. Interest is equal to $800. You're strictly paying 8% per year on the use of $5,000 over a 2-year period. There's no interest paid on interest.
How are you going to round it off on the month? Are you going to leave it all the decimals?
We're going to round our money to 2 decimal places because we're going to round it to cents. Are you ahead of me?
Well, like 8 months.
Right. She's looking at the next one, so let's just do it. Okay? Is that where you are? Okay, here we go. The next one says, find how much interest we're going to pay on $1,200, 8 months, 6% interest. We always start out by remembering what the formula is. The principal is $1,200. The rate is 6%. And the time is 8/12. You can, if you've got, well, in either calculator, this is going to work fine. We're going to go 1,200 times 0.06 times 8 divided by 12. It'll take care of it for you. 1,200, whoops, times 0.06 times 8 divided by 12 equal 48.
Can you use the decimal?
And she's saying 8 divided by 12 equal. If you do that, and I'm going to get here, you need to carry it out that far.
You need to use the whole decimal.
We don't want to write it down as 0.66. You're going to be a penny or 2 off. But we're going to assume that we're working for a bank that's loaning out millions and millions and millions of dollars. So we want to carry the whole decimal. If we were going to do that one and do this first, we would go 8 divided by 12 equal, and then we're going to go times 1,200 times 0.06 equal, and you're going to have 48. We don't want to take that times 0.66. Is that all right? Does everyone get 48? Okay, the next problem says, find the simple interest on $15,000, 6.5% interest, 27 weeks. So we're going to, once again, And you can just stick that in your calculator. I ended up with $506.25 worth of simple interest. Okay? So when you see weeks, the time is divided by 52. When you see months, the time is divided by 12. And when it's in terms of years, you're fine leaving it the way it is. Let's go back to years then. Find the simple interest on $600, 8.5% for 5 years. $600, 0.085, 5 years. Is that one all right? Now, you know we always have to have things that are kind of quirky. Yeah? All the little bells and whistles and toots, yes? We're going to talk about time now when it's expressed in terms of days. There are two methods used to calculate interest when we're talking about interest in terms of days. One is called ordinary, the other is exact. We've had banks around for hundreds of years. We have not had calculators and computers around for very long. I actually can tell you that it was the late 60s before the first handheld calculators came out, and those came out costing $400 and $500. So it was very uncommon for people to have calculators until really, you know, the last 20 or 25 years. Banks been loaning money for a real long time. So traditionally, to keep the numbers clean, banks decided that when interest is done on a daily basis, when you take out a loan for 180 days or 90 days, yes, instead of having complicated numbers that you get using 365, which is how many days there are in a year, we have interest that's based on a number that's called ordinary interest. And that assumes that the number that you use for time in the denominator is 360. It makes 180 days an exact half year. It makes 90 days exactly. It's a cleaner, neater, less complicated number. So banks traditionally use what's called ordinary interest for daily loans. Not an issue when we deal with year, month, or week. But if you borrow for so many days, then we've got to decide whether it is ordinary or exact. If interest is ordinary, which is used by most banks, the denominator that we use is 360. I remember that because it's 360, and ordinary starts with the O, so 360, ordinary, yes? And there are exactly 365 days in a year. So if it's an exact interest, then it's 365 days. Most banks and financial institutions use ordinary interest. Most government and like Federal Reserve loans would be using exact, okay? We will always tell you on daily loans whether they're ordinary or exact. And if I don't, you need to ask me because it makes a difference. But I try to be very conscientious about putting in either the word ordinary or exact. So we're going to talk about simple, ordinary, simple, exact when we're talking about the kinds of loans these are. We're going to be back using our table of days. If you have your pink sheet with you, get it out. Because the other thing we're going to need to be able to do is when we borrow money on a certain day and we're going to pay it back on a different day, we need to know how many days that loan is for. So, for example, let's assume you borrowed money on July 9th and you're supposed to pay it back on December 24th. How many days would your loan be for? Borrowing money July 9th, paying it back December 24th. How many? 168 days, that's right. December the 24th is day 358. July 9th is day 190. What we're going to do then is take 358, subtract 190, and say that loan would be for 168 days. Is that one all right? Is everyone okay on the first one? Okay, we're going to make it a little more complicated. We are going to take out a loan on May 12th, 1996, pay it back on March 5th, 1997. It's a leap year? It is or it is not a leap year in there? No. Yeah, I took care of it. There's not a leap year there. It's already passed, yeah. So what I see is that May 12th is day 132. The end of the year would be day 365. Does that make sense? So I see until the end of the year, I have 233 days left.
So we just subtract from 365 the 132 from 365?
Yes, and that'll tell you how many days you have until the end of the year. And then I noticed that March 5th is day 64, so that would extend 64 days into the new year. So I say, how many days are there from May 12th until the first of the year? And then how many days are there from the first of the year until March 5th? That'd be 297. And if there was a leap year involved in there, which we eliminated any of the February stuff.
Still, wouldn't you add a day to the
Day 1997 is not a leap year.
Oh, okay.
Are you with me?
Yeah.
If that had been in 1996, you would.
Okay.
Yeah. Is that one all right?
Yeah.
Okay, here we go. I've got December 21st, 1997 through January 6th, 1999. How many years are involved here? And 2 part years. So you're kind of going to have to deal with 3 years total. Does that make sense? So what I did here is said there's 10 days left until the end of the year. I've got a whole year of 365 days and 6 years into the next year. This is 97, 98, 99. I've got a total of 381 days. So we're just kind of reviewing how to handle that table of days. So if I told you we borrowed money on a certain day, we were paying it back on a certain day, you'd be able to figure out how many days had passed. We're also going to use the table of days when we make partial payments later on. We know how many days it's been since our last payment.
We do this the same way as we did on the front.
Okay, is everyone okay on 381 days there?
Remember, ordinary you're using 360, and for exact you're using 365.
Yes? Okay.
It just matters for this.
So, coming down to the next problem, it says, I've taken out a loan for $15,000. It's at 11% simple interest for 180 days. Tell me how much interest I'm going to owe if I'm calculating it using ordinary interest. When I say ordinary, you should think ordinary, 360. That's how come I wrote that, yes? So you're going to use principal equal 15,000. 0.11 is my 11% changed to a decimal. And I'm going to have 180 divided by 360 because it's ordinary for the time. When I put that in my calculator, I end up with $825 in interest. 11% is pretty steep interest. And you'll see I used all sorts of examples from 3 and 4% clear up to 15 and 16% in here so that we kind of get used to dealing with all sorts of interest rates. Since I've been teaching this course, these interest rates have been all over the place too. Is everyone okay with 825? Okay. The next problem, or the next part of this says, what if this was what if this was exact interest? I would then use exactly 365, yes? Same setup exactly, 15,000, 0.11, 180 over 365. How much interest would you pay? $813.70. So, ordinary interest causes you to pay more interest than exact. And what's Keegan thinking? You had a smirk. You were thinking, why would banks stick with tradition, right? They get more money.
I'm laughing at them.
Oh. What's really stupid?
That one would use 360 days and one would
If you
use
were a banker,
365.
would you become traditional or swing on into computer usage?
Traditional.
Sure, they make more money. It's a nice tradition, right? And again, you've got to think about all the loans made in banks. I don't know how many daily loans there really are, but they're not unheard of. Okay. So daily, you have to know whether it's ordinary or exact. And you'll always pay more interest ordinary. Okay? Okay, so here we go. Next problem says a loan is made on March 15th for $21,850. It has an interest rate of 14.5%, and it's going to be due on October 3rd. Find the interest due. We're going to use ordinary interest, and we're going to use exact interest. So we know what day we borrowed the money, we know how much money we borrowed, we know what interest rate. So what we need to do is figure out how many days. The day I borrowed it was day 74. The day I'm paying it back is day 276. How many days is that loan for? 202 days. And why would someone borrow money like that? Can you think of a reason that somebody would go in and say, it's March 15th, I need to borrow the money, and I'll pay you back October 3rd? Huh? And you knew you had money coming due on October 3rd for some reason, and you knew you'd have the money to pay it back at that date or something. Okay. Okay. So what did we get using ordinary interest? Ordinary is 360. I got $1,777.74. Okay. Using exact interest, I'm just going to do everything exactly the same except change that denominator to a 365. And I can scoot that up and say $1,753.39. Okay. Questions about ordinary or exact? Okay. If you don't have a calculator that has memory in it, make sure you bring your, or if you do, if you don't know how to use it, make sure you bring your manual or figure out the memory, because what we're going to do in our next session is not only, you don't like to use your memory? Got to find that manual, right. Because what we're going to be doing the next time we get together is not just finding the interest, but if I give you other parts of the formula, like I give you the interest and I give you the principal and I give you the rate, we're going to come up with the time. If I give you parts of it, you can come up with other parts. In this case, I gave you principal, rate, and time. You were always calculating interest, and we're going to calculate the other components if we've got interest. And it really helps to have the memory in your calculator for what we're going to do with that. Okay, let's get out our books and let's look at some of the homework then. We're going to be doing 1 through 39 odd on page 193, and let's see what that looks like. What are the first few problems doing, Karen? Finding the number of days. Is there any problem doing any of those? Do any of those look like they're over a leap year?
Yes.
Number 3, okay. I think we'd like to do number 3 then and practice that one. When does it start and when does it end?
April 7th of 99 to May 13th of
Hold on, April 7th, 1999.
to May 13th of 2000.
Okay, May 13, year 2000. And I was going to say, I think that what we need to do is talk about leap year just a little bit. I see that April 7th is what day?
97.
97, they're saying.
Oh, I thought you just wanted what it was off the chart.
Well, I thought that's what it was. It's day 97?
Okay.
Okay. From April 7th to the end of the year, this would be day 365, right? How many days would there be? I would take 365 and subtract 97. How many days do I get in there?
268.
268. So this is 268 days. Now, I'm going clear out to May 13th, year 2000. How many days is it from January 1st to May 13th?
133.
133. And then you say to yourself, is it a leap year?
Yes.
It is a leap year. So what happened after the day February 28th? There was a day February 29th. So instead of this being 133 days, it's 134. So in that particular time frame, with those years involved, it was a leap year, I need to add 268 to 134. And you need to watch out for those leap years in your homework. So how many days have passed? 402. Okay. So that's what you're going to do in that first set of homework. What happens in the next set of homework, Fran, the next type of problems?
Simple interest.
Simple interest. Are there any there that we need to talk about? They're years, okay. A couple of them are months, and when it gives you, what are some of the months they're using?
8 months.
8 months, so it'd be 8 divided by 12, 3 months. Oh, let's do that one. Let's do the one with 7 1/3. We need to talk about how we do that one in our calculator. Give me that problem. Which problem is it?
Number 13,
Number 13, because we haven't done those.
the principal is...
Hold on. P equal,
1,650.
okay,
The interest is 7 1/3%,
the rate.
the rate,
7 1/3%, okay.
and the time is 9 months.
Okay, we do need to do this one. Okay. Those of you that have your business calculator, first we're going to do I equal P times R times T. I equal, and we know this is 1650 times 0.07, whoa, and a third, right? And this is times 9 over 12. We need to handle, oh, this one is kind of complicated to do, all right? Okay, here we go. This really is, we're going to handle this first. We're going to do 1 divided by 3 equal
0.3 repeating.
plus, let me think about how we're going to do this one.
What number is it?
13.
All right.
Plus 7.
7.3 repeating.
7. And then we want to divide by 100. To be precise, we really do need to carry that decimal. The question is how many decimal places are enough. If you do 1 divided by 3, it will give you as many as your calculator can store. Okay? Are you with me? Did you get 0.07333 repeating now? You can then, so we've got that in our calculator, take that number that you've got, which looks like 0.07333, and it goes on and on and on. Then you can do that times 1650 times 9 divided by 12. And I'll tell you another way of doing this one. What are we getting on that one, somebody? 9075. Is that what anyone else got? Okay. I happen to like to use the memory. I would do 1 divided by 3 equal plus 7 divided by 100. Stick that in my memory. I'd store that.
All you do is press the store.
Do you have this calculator? Here we go. Okay, here we go. That's how come I wanted to do some of these homework problems. I'm going to hit clear. I'm going to do 1 divided by 3 equal. Then I'm going to add 7 to that because it's 7 1/3. So that took care of the third. Plus 7. Right? Now I need to change that. That's 7 1/3 in percent form. Right? I need to change it to a decimal, so I need to divide by 100. There's the decimal that I want. 0.0. And there's a decimal right in here. Too close. That's not 2 zeros. There's a decimal between those 2 zeros that maybe you can't see. Okay? Then what you need to do is, and I'm going to widen out here just a minute. Then you have a store button. Store it. So it's in memory. Now, come along and go. Don't hit clear twice. 1650 times, and you're going to hit recall second mem. It pulls that out of memory for you. Oh, did we hit times first? Yes. Equal that times 9 divided by 12 equal. Okay, let's do it one more time. Are you ready? Hit clear. Clear it all out. I'm going to go 1 divided by 3. That's my third. So it's 7 1/3. So I'm going to go plus 7. I'm going to divide it by 100. That gives me the correct decimal. I'm going to try turning off this light and see if it... Nope, that doesn't help, does it? Does that make it better? Nope, that doesn't make it better either. Okay. So then we're going to store it. All you have to do is store it. That holds it in memory. Okay? Now, then we're going to come and go 1650 times. I'm going to hit recall second. It pulls that number right out of memory for you. I took it times that, and then I'm going to do it times 9 divided by 12. And I come up with my number pretty straightforwardly. So I like to handle those. Now, we don't need to do that when it's 7 1/2 because we can convert it to 7.5. We don't have any round-off problems. It's only when the denominator is a 3, a 6, a 9, something where I'm going to get a repeating decimal, and I need to carry that decimal with me. Some people would say, well, I just will enter 0.33333. How many threes are enough? Do you have the same calculator I do? Well, tell me what you're pushing.
Second recall after I store it, is it second recall?
No, you hit recall second, and then the memory, which is above the 0.
I was doing it that way too.
You recall memory. It's recall second mem. Did that work? Once you get in the habit of using that memory, it's not as awkward as it seems on first observation. Okay. What else is our homework looking like?
0.085, is that the answer?
No. We're getting 90.75. Okay. Recall second mem and tell me what's in your memory, Christine.
0.073333.
Okay. So,
Can I just straight out multiply?
yes, go 1650 times, then go recall second mem, And it should pop up with 0.07333. Okay, times 9 divided by 12.
I didn't divide it.
Ah, okay.
That was it.
90, 75.
Okay.
Do the last step.
All right, so you're getting the right answer now. Is that all right? Okay. All right, let's look at the rest of the homework. Is there anything else that looks like something that would be awkward when we got home? Thank you for bringing up those fractions that were not easy to be converted to decimals.
Just out of curiosity. Number 14, one we don't have to do.
All
It would
right.
be 0.05.
I don't have my book. Tell me what it says.
It says 5 1/6%.
All right, let's do
So
that
it
one.
would be 0.05.
Wait a minute, 5 1/6%. Okay. I'm
So it would
visual, I
be
have to write it down.
0.05666666.
Yes, it is.
All right.
And how you would get that is 1 divided by 6 equal, and then you're going to say plus 5, and then you're going to divide that by 100, and it should be, no, what's 1 divided by 6? I'm sorry.
0.166666667.
So it's 0.0516.
0.0516666. I was going to say, when I looked at that one again, I thought that's not right. There you go. Yours might have a 7 at the very end to show you that it's rounding up, but in your memory, it's actually not rounding up to 7, it's holding it to 6. It's just showing, the memory of your calculator goes out more places than your screen. I don't know if it goes out either 8 or 12 places. So the memory is not really rounding at that level, it's just showing you it continues on. Again, when we're dealing with $1,000, we could just put a few sixes and it would be fine. But if we're really in a bank or something, if we're in a company, you think about the kind of money that companies deal with. We're talking about millions and millions of dollars. We really do need to carry that out to those 12 repeating sixes or whatever. And calculators are very capable of holding that. We just need to know how to use a calculator so that it does hold that in its memory. And I think that with the use of calculators, it's not unreasonable to expect precision. We don't want to be off by $100 here and there. Okay. Are there any other problems in the homework that look, and that was a great one. Thank you, Keegan, for bringing that one up, because that was another example of one that had a denominator that needs to be addressed. And there are probably other ways of handling those denominators. That's just the way I prefer it. Okay, are we done with everything we need to do before we take off? Okay, then we'll have them turn off the tapes. If you'll let them wait till they're turned off, we'll be done.